جولة خارجية على المبنى سريعة. هذا تربنتين الظاهر. شوف كيف الكتلة نافذة وعامل هنا جسد خارجية مظللة، تأثيرات رأسية. هذه الواجهة الجنوبية دي طبعا. بس لاحظ السولر فوق، يعني مظلل الجلسة الخارجية بسولر. لاحظ المتعب رهيب صراحة كذا. اللاندسكيب كيف بسيط. جميلة الفرزة دي، طلع حلوة. طبعا يقول لك زاد إذا جاء الشمس يتظلل من نفسه زي النظارات الشمسية ذيك. شوف المظلات، الناس كيف بسيط رهيب صراحة. بعدين فيه الألمنيوم مخرم بالليزر بوسط المظلات. طبعا هو الآن تو ما انتهى 100%، قل شوي. طبعا هو مستخدم الألمنيوم لأنه أسرع معدن يفقد حرارة، وأسرع معدن أكيد يكسب حرارة، نستخدمه احنا بالطبخ. فهو معدن على طول يكسب حرارة ويفقدها. ففي 4 إنشز يعني سماكة يمكن 10 سم 15 سم بعد الألمنيوم هذا على الجدار، بحيث يصير في طبقة داخلية بالهواء تصير عازل بحد ذاتها. وبنفس الوقت الكابر، أريزونا مشهورة بالكابر، فهي مادة محلية. والألوان هذا الحمراء زي ألوان الجبال، فهي من الكلتشر المحلي لأريزونا. هذه نقطة للمصمم. الناس يسألون وش دخلهم الحضارة، وش دخلهم الفلسفة، وش دخل من هنا، من هذه الأشياء العميقة. اختيار المواد، نوعية المواد، لونها، من نفس البيئة. طبعا هذه الواجهة زي ما قلنا الجزء هذا فيه ألمنيوم مخرم بالليزر، بحيث الشمس إذا جت هذا الجزء هذا مخرم بالليزر، الجزء ذا لا ما مخرم بالليزر. عشان يقول عجبني اللاندسكيب كيف بسيط. المدخل كله زجاج وفي مظلة، خلي الناس يحبون يجلسون يفكون. الواجهة الغربية مليانة كاسرات أفقية، مع أنه المفروض رأسية، بس يعني المعماري مشى مع الشكل أكثر. شوف كيف المياه كيف تتصرف من هنا، لأنه المبنى هذا زيرو. وش كاتبين وين هم موجودة؟ زيرو انرجي وزيرو ووتر، أو نت زيرو انرجي نت زيرو ووتر، يعني إنهم ما في ويست للووتر، وما كل الووتر يعاد استخدامه في الزرع ولا في ضخ قدرات المياه الله يكرمكم. يعني السيفون يعبي الراجع من المياه. أيضا هو صح مغلق الألمنيوم، لكن في أجزاء محفر. أنت إذا لقيت الدرج، خاصة منطقة الدرج تبي تناظر، أو بعض المكاتب تلاقي إطلاع له. صح إنه مغلق مصمت، لكنه تقدر تشوف من خلاله إذا صرت من جوا. بس لاحظ الحركة هذه، إنه الدرج هنا ناقز، لاندسكيب، مجمع المياه، وإذا أمطرت تتجمع المياه. مستغلين كل شيء، يعني كل نقطة من المياه مستغلينها. الدكتور هارفي، هذا الشباب، هذا هو المبنى. واحنا تحت شوي وفي مظلة فيه مدموج مع نظام السولر الموجود في الكامبس. فوقه في سولر، نشوفه هنا.
My name is Kendon Young. I'm the Student Involvement Coordinator here in the Memorial Union and the Student Pavilion, and my role is to increase the profile of sustainability through student leadership. Cool. So you all are aspiring student leaders in sustainability. Woo! So thank you for being interested at ASU and like seeing what you can be part of and how this can contribute towards advancing your green futures. So what you are standing in front of is the Student Pavilion, which is ASU's first and Arizona's largest net zero energy facility. So does anyone have an idea of what net zero energy means? Got a couple.
طلاب من شيكاغو جايين.
Probably has something to do with power. Might have something to do with the solar panels that are in front of there. So if you were putting 2 and 2 together, this building uses as much electricity as it consumes over a year. The AC up a little bit, but during the winter you don't need it. So the solar panels that you just walked underneath, as well as the ones that we just put on top of the building, are what neutralize or offset the power consumption over the annual basis. So So I want to make sure to introduce some of our team here that's really been instrumental in getting this building up and running. So if you want to go ahead and introduce yourself and
Say hi.
the departments you're in.
Hi, I'm Alana Levine, and I'm a director in facilities development and management. And I was privileged to be part of the team that took down the building that used to be here and built this building up, and part of the team that now kind of runs it. And my role at the university is actually over grounds and the zero waste initiative. So all of the solid waste issues, all of that kind of stuff, I get to play with all of those pieces of this. Yeah. Cool.
Go ahead. I'll let you next. Well, all right. I'm from Chicago. Operating maintainer essentially for the university, and that is my role here. But I'm also from St. Louis, go Cardinals, and I hate everything about Chicago.
Forget that last part. I heard he loves Chicago. That's what I heard.
Your pizza's okay.
So I think one of the really important parts about the team that you're seeing standing up here is that we represent different parts of the university. There's an architect's, we have Pedro from the architect's office. We have Alana from the zero waste team. We have Alexander. I was going to call you Alex.
You call me Alex.
Alex. Alex from the facility side. So we've all tried to, and then myself from the educational side. So we brought all of these different spheres together so that we can really advance a culture of sustainability, not only through the built environment, which is very important, but also through the engagement of how we use the building, how we are helping students understand.
If you were a student, your student fees pays for this, and pay. That building over there and this building here is actually managed differently than other campus buildings, even though we have some of the same staff. The resources come from different pots. It doesn't come from the Board of Regents necessarily. Yes. And it's managed by, again, different staff.
So thank you for reminding me. So in this building, we have the student. Go ahead. Oh yes, we will do that. So panels, right? So you see the solar panel array that is in front of the Memorial Union, as well as what you can't see are the solar panels on top of the building. So that's like on the roof that all contribute to offsetting the usage of the building. And then the way that we have actually structured the material layers, if you want to talk a little bit about the envelope.
Yeah, we can talk about the envelope. So, just a curious question: are you guys like beginning architecture students?
Yeah, high school students who
You're
are
high school.
Who are you guys?
I see. Okay. So, as Harvey can attest here, this didn't happen by magic. One of the things, if you go to architecture school and architecture programs, which I did many years ago, one of the heartaches you'll go through is that before you can put pen to paper and design a beautiful building, you have to do a lot of programming. Essentially what that means is you have to collect a lot of information from a lot of people to find out what makes that building a building. A year and a half doing the programming before anything happens. And in that programming phase and the initial phases of design, we did an energy model. And the energy model told us the energy consumption that the building needed to sustain itself, to have that net zero certification, if you will. One thing about net zero is it takes a year to certify. And the reason it takes a year is that we have to establish a baseline energy consumption, what's the building using, and then tweak the building, like tuning up your car, right? You have to tweak the building to get back to what your energy model was telling you it should be, and go through that year and then start measuring. What you measure electrical consumption, you measure HVAC, which is for us in the desert, is basically our air conditioning bill. Okay, and you measure all the loads and plug loads and One of the things we did for net zero is that we metered all of that. This building has the most meters, I think, on any other buildings on campus. The reason they're metered is that's how we collect the information. That's how we collect the data to measure. So one of the things we did for skin is we use electrochromatic glass, like for example that glass over there, has an effect that it reads the sun angle and the sun intensity, and it darkens. Okay?
So a really simple way to think about that are those that produce the need or the electricity needed to cool the building.
مثال النظارة حقت الرجل
The other
هذا.
thing that we did is that we our baseline energy model gave us the idea of what a building like this would be. Our baseline was simple. So we wanted to go way above baseline. So in order to achieve some of those energy efficiencies, we super insulated this building. Not only is there insulation on the exterior, there is spray foam insulation on most of the interior spaces as well to capture that cavity and just make it well insulated. You guys in Chicago, you know, in January, you're really grateful for the insulation in your house because you want to keep the heat in. Us, it's totally opposite. June, July, August, September, October, we want to keep the cool in, keep the heat out. Insulated as well. We have like a double skin layer. When we walk around the outside, you'll see some corrugated copper panels. Those copper panels provide, which is on the interior side, about 4 inches away, more or less, creates a chimney effect. And what that does is that it allows the heat that's building up along the perimeter of the building to escape, just like a chimney, and not sort of hit the face of the actual face of the building, which is behind those copper panels. Okay, a lot of entrances. We also super insulated the roof, and we have a pretty dynamic roof. Of course, it's a white roof because that reflects the most sun, so we're not trying to gather energy there as well. The other thing we did is we did a window to wall ratio calculation. So this building, as opposed to other buildings you may see not only on campus but around the valley, we don't have a lot of glass on this building. Of course, we wanted to celebrate the entry, so there's glass here, but there's not a lot of glass, and we don't have glass west or east, which are our most extreme exposures. That
uses something called an indirect adaptive cooling system. All the buildings for the last 60, 70 years in Arizona is air conditioning. And air conditioning uses a tremendous amount of energy. Before air conditioning, we used to use direct adaptive cooling. Sometimes it's called swamp coolers. And you still see that in some of the older communities in Arizona. But this building is actually using a new version of that, it uses indirect adaptive cooling. And it's unique. It's the first, what I'd say, large assembly office building that is using something other than traditional air conditioning. And that's another reason why it got to such low energy values, because they're looking at another technology. So we're actually going to test this system this summer during the peak, which starts in about a month or so, and see how effective it is. If it is effective, I think we can make a very good argument to the local engineering community that we can do more indirect adaptive cool buildings and bypass air conditioning. There is some air conditioning buildings adaptive cool, which is really new. It's an old idea, but we reinvented it to be used in a really large building. Relatively, because most of the adaptive cool buildings are residential buildings that still remain in Arizona.
So that's a great point, Harvey. So, yeah, go ahead.
I was just going to ask if we can talk a little bit about how that works.
Yeah. No problem. But to Harvey's point, it is an old idea. It's a beautiful idea. What's happening is that technology has caught up with that idea and made it so that you can make huge systems and apply them to large buildings like this. That system has been proven and used in Australia, another hot, arid climate, and they use it for a lot of applications. In the United States, they've been using it in areas that need a lot of cooling, like data centers, for example. The reason they use it there is that data centers produce so much heat, they have to capture the weather conditions inside that room, if you will, with the least amount of energy consumption. And indirect adaptive cooling provides that because it's so efficient. Go ahead, Harvey.
Right. Again, I'm sure we have really dry air here. So if you put a mist or a spray into that air on a hot summer day, it will create a cooling effect. I'm sure you've experienced it even in Chicago, which has a little bit more humidity than we have here. You see, actually in the summer here, we have restaurants that have misting systems outside, and you can eat outside. It's not too bad, but that's the fundamental concept of adaptive cooling. You add moisture to dry air, it cools the air significantly. Okay. So that's what we're doing here. But we don't have the indirect path. We don't have a direct system. We have it cooling dry. The dry air comes in, it gets misted or water sprayed into this chamber. And then we pass air that is coming into the building by that heat exchanger. So it's not direct evaporative cooling, it's indirect. We actually pass it by a second to get the temperature even further down because we want to provide the comfort levels that would be pretty close to what an air conditioning system would supply.
Think of it like this. So you have a fan, right? You're blowing air into a room, right? That air is the same temperature as it comes into the fan as it went by. Now put an ice cube in front of the fan. As the air blows by the ice cube, it's going to get colder, right? So it feels much colder. That's what that does. That air, that water gets ejected into that air column. It makes that air colder, but it's in a pipe. And that pipe, when the air goes by it, that air gets a little colder as it goes by the ice cube. That's what's happening in a heat exchanger system on it. So that's what you're doing. Remember, if you guys take any physics, you've heard of, have you ever heard of latent heat diffusion on that? Like, water can only get to 200.
هنا
based off of the angle and the intensity of the sun. You'll also notice there's horizontal louvers right to my right, your left. So that is a way in which we are breaking the path that sun gets to the building, right? So if you put something in front of a building, the sun is going to heat that or the heat into the building. You'll also notice that there's a big fancy staircase right in the middle. Has anyone heard of the Bullitt Center in Seattle?
yes.
A couple of people, I would check it out if you haven't. They're also a net zero living building but what they found by putting the solar or the stairs front and center into a building, that it increases usage of stairs by 70%. So why is that important?
Health.
Because it takes energy to get people up the stairs or up the elevator, right? So if we can divert people to using the stairs instead of using the elevator, you're able to remove as much power as possible. So it also promotes healthy living, right? Let's burn a calorie and not a watt. So with that, as Pedro mentioned earlier, our building is able to see how much power is being used per floor.
So real quick, it was a little warm outside. We came in this space. You're feeling the indirect evap cooling system on right now is what you're feeling. The largest space, the event center spaces in there, and this whole lobby is being cooled by those indirect evap.
The other feature about this space, which is invisible, is the fact that it is several stories tall. So with some, Pueblos, is anyone familiar with the dome structure, right? How hot air rises, cools at the top, and falls. So you're also using a very passive way to help cool the building by just creating more space and materials for the air to cool as it rises and falls again. Does that sound good?
Also, the floor is very important. It's polished concrete. We call it poor man's terrazzo. Terrazzo is that, you go into like a lobby of a big building, you see that polished floor, and sometimes you see inlays in those grinding machines. And it gives a nice look, but it's a very cheap product, and it's very small.
What is another benefit that you can think of from this type of flooring? Think about cleaning. Say again?
Simple to clean and simple at the same time.
Right. We don't need vacuum cleaners to clean concrete,
nice.
right? Just need a big old fancy Swiffer and just like Swift that stuff. All right, so let's move up to the second floor using our energy-free stairs.
رهيب. هذه أفكار حلوة. Anthony, enjoying?
Yes, I am. What about you?
Yeah, of course.
As you're walking up, take a look at the difference in color of glass.
الشبابيك هنا تغمق تصير مظللة من نفسها إذا جت عليها شمس. نوع من أنواع العزل.
Within architecture, we're able to hide things, right? So the fact that we have energy-efficient lighting means that we're reducing our consumption from lighting. But are we actually changing people's behavior on turning lights off when they don't need it? So some of the ways that I really enjoyed working with the team that helped build this building is how we can tie these behavior changes into the way that people physically interact with the space. So as we walk forward, you'll notice right here to our right that we've got our recycling and landfill bins. So this building was built, demoed. The original building was demoed with 99% aversion from the landfill. It means 1% went to landfill. That's it. And that was largely because of, or primarily because of Alana's team in being able to tool the way that we break down a building, repurpose the materials, and achieve that zero waste material went to reuse. All of that has created a drive that this building is a zero waste toolkit. So in that, we are committed to ensuring that this building will operate with a zero waste goal. And here at ASU, that is a 90% aversion from the landfill. So the fact that we have the recycling landfill bins up there, as well as composting, which is in our kitchen, we are able to capture all of those materials, divert them into the streams that they're supposed to be in, and help educate the people in the building on how that works.
Anything from carpet tiles going to the University of Phoenix Stadium to be used in gymnastics competitions to a really big old gnarled kind of olive tree that was on site that was going to have to come down anyways. That wood from that went into, some of it went into our art department here at ASU, and then some of it also went into some community carpentry programs where people were learning how to work wood, and they made pens out of it, they made bowls out of this cool tree. So not only did we look at how the waste from this site could be diverted from the landfill, but also how could we make other people's lives better or enhance our community through these materials. So that was really a unique part of this building as well. And continuing that into programming.
This is taking light from the roof and bringing it down in a mylar covered tube, and it's actually bending and doing this to get the light here. And so that's like a skylight in a way, but it's coming down through there's a story above us, so it's not necessarily on the top floor because we have these tubes that bend that light to get it to where we want it. And you can actually put LEDs inside them and run them at night as well, and they can be both daylighting use as well as the nighttime use on them. And they can be turned off if you want to darken space and things like that.
So if you look at it from this, it's bent sideways.
So there's a chase that goes up to the rooftop, which is a story about it. Comes down and bends that light to direct it right here.
So is anyone familiar with like submarines and the periscopes or whatever those are things? You look up there. It's the same thing except we just cut off the top and the sun comes down, right? So glass line there, but then to my left, your right, there is massive glass, right? So the fact that we have less south exposed sun coming in, right? The angle is not hitting the building at that intense angle means we can afford to have more glass on this side without gaining more heat. Versus to the north, where anyone know what latitude we're at? Come on, architects. 33 1/3 degrees is Phoenix's latitude. So I would challenge you to look at what latitude Chicago is at and how you are able to align your glass in buildings that you build to maximize the amount of heat gain, especially during the winter, and minimize heat gain during the summer based off of how you place your glass. So we have sun coming in from the north side in very minimal windows. Wasted energy, obviously, is putting natural light in the middle of the space, but also being able to shut off outlets every night at 11 p.m. So there are outlets in this space that are identified with a gray ring around the particular outlet that will turn off every single night at 11 p.m. to address phantom load. Is anyone familiar with phantom load? Got a couple. Anyone have a TV at their house or in their room? How many of those TVs have little red lights to tell you the thing is off? Oh, weird. It provides no function. The TV has got a little light to tell you the thing is off, and you're like, I know it's off. There's no TV playing, right? So that is a concept that devices are draining our grid without providing function. So the outlets that have the gray lines are intended to help address that. So there's all sorts of other parts of phantom load. So how many of you plug your phone in at night? That entire time. So that's, again, where behavior change comes into play. and how we can place specific signage in this space where people are going to plug things in to change that. So I think Rainbow Coalition, and we might need to look at your outlet if you're cool with that. We can cycle in through there and look at the little gray line around the outlet, as well as if you look over the top, you'll see the palm trees out front. Those are actually date-bearing palms that are provide a larger shade radius than a traditional like California palm, and they produce dates. It also kind of looks like Jurassic Park out there with all the crazy little ferns. So that's another way that we've inadvertently cooled the space and created an opportunity for people to program out there.
So you notice how quiet it is, not only because it's kind of a quiet space, we have a lot of no air moving around. It basically, it's not quite passive. There is a fan that's pressurizing the air coming out of these things, but it's very different than a traditional air conditioning system that has lots of registers in the ceiling and blowing a lot of air through the space. This is a very casual, drops the air, uses gravity and some mechanical energy, drops the air really gradually, and it's a very efficient way of distributing cooling to a space. And it's a new concept that we are really happy with. It works really nicely with our indirect evaporative cooling system.
So any questions?
The sustainability going into the future. And my comment on this is I have a different perspective than everybody else because I get, these guys build these wonderful buildings and I love them and they're fantastic. I got them for 50 years after that. So we really have to think about long term what's going to happen. The one thing I would say is architects, you got to think not just beyond the beauty. That's what I would challenge you all to do. Beyond the beauty is it, and how are people going to react to it, and how is that going to happen? What are we asking people to live with from a sustainability perspective? So chilled beans, we talk about these chilled beans. These are wonderful products. They absolutely are. They're very low flow though. So if you put them here, great. If you put them in by the front door and you open the door out there, there's not enough air volume to make up for that. So we have challenges. So you have to make sure that you have very sealed spaces. This is a great building. It's got a double skid on it. If it didn't, and you tried to retrofit a building with a very thin skid on it, we'd have to come up with some other solutions. You have to think beyond the beauty. You also have to think beyond the functionality of it all. This is a great flooring system. It's concrete. It's indestructible out there. You want to view a beautiful floor on it, how many people are going to walk across it? You got to think about that. Painted handrails. I have a campaign against painted handrails. We have 100,000 people that come here every day that love to rub their hand up and down the handrails. If you paint them, I will paint them every month. In order to be sustainable, don't make me manufacture paint. It's incredibly manufactured. So that's my challenge. Where is sustainability going? Sustainability is leaving the new fancy technology, and it's going to get more mundane, unfortunately, if we're really going to be successful at it. We got to get back to the basics of sustainability. The new technology is great, but we really got to just start thinking about making good decisions. That's where
of sustainability, which you will be visiting a little later today, I believe after lunch. Thank you very much, you guys.
Thank you. Thank you.
Ray, if it's possible to take 10 minutes from
We're cutting into your time, so whatever you want to do.
I think that's okay, because we can...
هذا الولد دارس sustainability بالبكالوريوس، والماستر دارس education. وظيفته أو يطمح إنه يسهل السيستمز للطلاب والعامة يعني بحيث يشرحها بلغة سهلة. 4th grade level يعني. Hi Professor, you know Saudi Arabia signed the biggest solar project contract. What do you want to say about that?
Again, I think everybody in the solar field is very excited about that contract because it actually was a very low cost response to the proposal that the Saudi government proposed. And I think what it's done is made a lot of people very aware that these large-scale, utility-scale plants can come in very affordably, be built. And so that's very exciting. So we're looking forward to seeing that facility being built in Saudi Arabia and hopefully some others, because it's driving the market to create lower and lower prices for large-scale solar facilities.
Nice, nice. Thank you, and thank you for your all information.
Okay.
Thank you. Bye-bye.